This is a perfect question to understand that how distributive the limit is. As we have discussed earlier as well, that limit is a highly distributive function. Plus, minus, multiply, divide, सब में distribute कर सकते हैं. For that, limit x tends to 1, x plus x square, and so on till x to the power n. This n, can we write as 1 plus 1 plus 1 and so on till n times whole upon x minus 1? Is it clear? n को break कर लिया 1 plus 1 plus 1. The logic for this is limit x tends to 1, this x minus 1 together. Then x square minus 1. Then next term will be x cube minus 1. And so on till last term would be xn minus 1. This x minus 1 can be written in the denominator with every term. Is it clear? Is this clear? Now this will be limit x tends to 1, x minus 1 upon x minus 1. Limit x tends to 1, x square minus 1 upon x minus 1. X tends to 1, x cube minus 1 upon x minus 1. Limit x tends to 1, x n minus 1 upon x minus 1. सबके साथ लिमिट को डिस्ट्रीब्यूट कर. Now here the first part is very simple, only one left. Can we write this one as 1 square? xn minus an upon x minus a, n minus 1. So 2 into 1 raised to the power 1, so just 2. This will be 3. And so on. This will be just n. 1 plus 2 plus 3 till n. Sum of n natural numbers is n plus 1. That's not possible. Got this? How many of you had already done it? No one. Okay. So which operator is one? Now look. Question number 1. Nobody is going to write anything. समझो पहले इसको. Limit x tends to 0 sine 11x upon 7x. The constant terms can be written outside the limit. जैसे ये वाला जो 7 है इसको हम बाहर लिख सकते हैं. Sine 11x upon x. Is it clear? Now it is 11x, but here we got only x. तो ये जो मैनिपुलेशन यहाँ इस पर्टिकुलर एक्सरसाइज का जो कीवर्ड है वो मैनिपुलेशन है, ट्रांसफॉर्मेशन. Look carefully. If we multiply and divide this by 11, so now this is sine 11x upon 11x. Already extending to 0 hai, so that's already there. Now sine theta upon theta will be 1. So this will be 11 upon 7 into 1. The result is 11 upon 7. Right? Look for the second question also. Somebody please read it out. Second question. Sine 4x upon tan 3x. Now look carefully. If we divide numerator and denominator by x, this will be limit x tending to 0, sine 4x upon x, whole upon limit x tending to 0, tan 3x upon x. Right? We can multiply and divide this by 4. We can multiply and divide this by 3. Right? So now this part will become, so this will be 4 upon. Followed. So इस पर्टिकुलर एक्सरसाइज में हमें ये ट्रांसफॉर्मेशन ही सीखनी है. Dividing numerator and denominator by x. This thing you'll get by practice. Limit x tends to 0, tan 3x upon x, minus 2 outside, limit x tending to 0, x upon x, limit x tending to 0, 3 outside, x upon x, plus limit x tending to 0, sin x upon x. Is it clear? Is it correct? It was sin square x. So can we write it this way? Limit x tending to 0 sin x. Clear now? Write this out. बोलो. Upon x यहाँ नहीं आएगा ना, एक ही x से तो. Here we need 3. Now tan 3x upon 3x. 1. So this will be 3. These two cancelled. So minus 2. Whole upon these two cancelled. So only 3. Plus this part will be 1. Sin 0 is? Sin 0. 0. 1 upon 3. Right? Is it difficult? Just a quick recap. Look, cos 2x we have written as 2 cos square x minus 1, minus 1, minus 1, minus 1, minus 2. 2 we have taken common, a square minus b square, a minus b, a plus b. ये दोनों cancel हो गए, cos 0 is 1, 1 plus 1, 2, 2 into 2, 4. How to do this one? Sin. What's the formula for sin c minus sin d? 2 cos c plus d upon 2 and sin c minus d upon 2 and whole upon x. Quit out. This 2 being a constant outside, या फिर इस 2 से वाला 2 कैंसिल कर सकते हैं? कर देते हैं, क्या जाता? Can we? Why not? It's with the angle. X and x cancelled. So this will be cos 2 into this 2 and this 2 cancelled, sin x upon x. Right? ऐसा नहीं होना चाहिए था ये x दोनों के अपॉन में आता. नहीं होता. अगर बीच में प्लस या माइनस साइन होता तो हम इस x को फिर दोनों के अपॉन में. But क्योंकि multiplication sign है, so it will be written below the required term only because it is sin x upon x which is 1. We don't need x here. तो हमने इसको blank छोड़ दिया, x को इसके साथ shift कर. Right? Right? So this is 2 cos 2 into 1. Answer is 2 cos 2. Two cos t plus a upon 2 sin c minus d upon. C plus d upon 2 sin c minus d upon 2. खुद की मैं उससे क्यों पूछूंगा? आप पे भरोसा करता हूँ मैं. ये थोड़ी भाटिया पे आपसे ज्यादा भरोसा करूंगा. Now look. Limit x tends to pi, x minus pi whole upon sin x. Can we use those three standard results directly here? Can we use those results, sin theta upon theta or cos theta upon theta? If not, why? Because x is not tending to 0. We can use these results only if x tends to 0. The variable should tend to 0. It is not tending to 0, it is tending to pi. So those standard results cannot be used directly. So अब अगर directly use नहीं हो सकते तो indirectly use होंगे. Use तो करनी पड़ेंगे वो वाले results. So इस pi को हम इधर shift करते हैं. If we shift pi to this side, this will become x minus pi tends to 0. Is it clear? X minus pi tends to 0. Now we can write x minus pi as, we can take x minus pi as t. If x minus pi is equal to t, x will be equal to pi plus t, right? So this will be limit t tends to 0, t in place of x minus pi t, and in place of x, pi plus t. Now pi plus theta, which quadrant? Third. Third quadrant sign will be negative. Will the function change? No. So this will be limit t tends to 0, t upon minus sin t, right? It is sin t upon t which is 1. तो उस फॉर्म में कैसे कन्वर्ट कर सकते हैं इसको? Reciprocal. So minus 1 divided by limit t tends to 0, sin t upon t. So minus 1 divided by 1. Answer is right. What should be the first step? Very good. Limit x minus 1 tends to 0. After this, x minus 1 equals t. We'll take x minus 1 equals t, so x will be equal to 1 plus t. So over here it will be limit t tends to 0. In place of x minus 1 t, in place of x, 1 plus t and whole upon sine pi as it is. Can we write this as sine pi t upon 1 to complete the fraction? So that it can be written in this form. So this will be limit t tends to 0, t upon 1 plus t into sine pi t. Right? Now watch out carefully for this. Limit t tends to 0, 1 upon 1 plus t divided by limit t tends to 0 sine pi t upon t. What I've done over here, 1 upon 1 plus t separate, t upon sine. This should be sine upon t, so reciprocal. What else do we need here? Pi. So pi and pi. Now here we can put up the limit. If the form is not 0 upon 0, we can put up the limit. So this will be 1 upon 1 plus 0. So 1 divided by pi into 1. Result is 1 upon 1. एक बार देख लो पहले इसको आप. See, obviously we will not be able to use the formula directly because x is not tending to 0. अब अगर हम जो सेकंड मेथड अभी हम कर रहे थे, अगर हम pi upon 6 को इधर शिफ्ट करते हैं, फिर वैल्यूज पुट अप करते हैं, the whole thing will be very complicated. Are you getting my point? यहाँ जो ये क्वाड्रेटिक एक्सप्रेशन गिवन है, अगर हम इसको फैक्टराइज कर कर कॉमन फैक्टर कैंसिल कर दें, the things will become easy for us. Are you getting my point? थ्री पॉसिबिलिटीज हो गई. या तो हम डायरेक्टली फॉर्मूला यूज करेंगे जो यहाँ पॉसिबल नहीं है, हम लिमिट को इधर शिफ्ट करेंगे, कर सकते हैं, बट इट विल बी कॉम्प्लिकेटेड. तो थर्ड पॉसिबिलिटी that we simplify, we factorize. यहाँ पर क्योंकि factorization possible नहीं, the way we do it for quadratic equation. So this is 2 sine square x plus 2 sine x minus sine x and minus 1. 2 sine square x minus 4 sine x plus sine x plus 1. Limit x tends to pi upon 6. 2 sine x common. This will be sine x plus 1. Minus 1 common, sine x plus 1. Whole upon 2 sine x common. This will be sine x minus 2. So sorry. It should be minus 2 sine x and minus sine x. So this will be minus 1 common and minus 1 common. This is also sine x minus 1. So now this will be limit x tends to pi upon 6. 2 sine x minus 1 and into sine x plus 1. Whole upon 2 sine x minus 1 and into sine x minus 1. Is it clear? देखो प्रॉब्लम भी इन्हीं दोनों टर्म्स की वजह से होती है. रीजन, अगर हम x की जगह पाई अपॉन 6 पुट अप करते हैं, sin पाई अपॉन 6 sin 30 डिग्री, sin 30 डिग्री इज 1/2. 2 into 1 upon 2 1 minus 1 0. 2 into 1 upon 2 1 minus 1 0. ये प्रॉब्लमेटिक टर्म कैंसिल होगी, बाकी जगह हम लिमिट पुट अप कर सकते हैं. इन प्लेस ऑफ x वी कैन राइट पाई अपॉन 6. So 1 upon 2 plus 1, 1 upon 2 minus 1. This is 3 upon 2 minus 1 upon 2. Answer is minus 3. Right, Vansh? Try doing it without looking at the board.